Hi, if you're watching this video, you're watching the fourth lesson in optics. In this lesson, we'll be talking about lenses and what they are. So all of you have seen a lens at some point, and if you've ever used glasses, then you've definitely seen lenses. So, what is a lens? A lens is a clear piece of material that has been designed to bend light. So, when you look at a lens, it's a clear piece of material designed to bend light. And if you paid attention in our previous lesson, you'd know that when light moves through something and it bends, that's called refraction. So a lens is basically a material designed to refract light. So as light would hit this object, it would bend a certain way. Maybe not so dramatically, but it would bend the light. So a lens is an object, a clear object or material that is designed to bend light. There are two types of lenses, and this may sound familiar, but there are convex lenses and concave lenses. Right? Now, when we talked about mirrors, we talked about convex and concave mirrors. And they did certain things. So concave lenses focus light and flip the image. Right? So when light passes through a convex lens, light is focused into a certain spot. It also causes the image to flip. So convex lenses focus light and flip the image. Concave lenses do the opposite. And remember, I like to think of concave as cave in, like it bends in, while convex sounds like flex, and it looks like a muscle flexing. A concave lens scatters light, so as light moves through it, it'll move out like this. Well, they wouldn't cross over, but they'll do that. And they'll scatter light outwards. Right? So they spread light out. And you may be asking, but didn't concave focus light? Concave mirrors focus light. Convex mirrors scatter light. For lenses, convex lenses focus light, and concave lenses scatter light. So, depending on if we're talking about lenses or mirrors, concave objects of this respective type will do the opposite. Concave mirrors focus light, concave lenses scatter light. Convex mirrors scatter light, and convex lenses focus light. So, just like before, I thought concave flipped the image. Concave mirrors flip the image, and convex lenses flip the image. Right? And so in this picture, you can see the light hitting the giraffe, goes through the lens, gets bent downwards, and ends up down there. While the light from the feet go through the lens, bend upwards, and end up here. And so that's why images look flipped through a convex lens. Now with a concave mirror that does the same thing, right? The light from the top hits the mirror, goes down, and is now down here. Right? The light from the feet hits the mirror, right? And ends up here. Right? And so the image will look upside down. So, convex mirrors versus concave lenses. Convex mirrors spread light, right? When we were looking at this mirror, the light was bouncing off in different directions. But concave lenses also spread light. So when light hits the object, or hits the lens, it spreads outwards. So convex mirrors and concave lenses scatter light, while convex lenses and concave mirrors focus light and flip the image. How do we use lenses in our everyday lives? Well, glasses, for example, binoculars, telescope, cameras, our eyes, all use lenses in our everyday lives. These objects are used. If you need glasses, which is what a lot of people need to use to be able to see, they require lenses. If you wanted to see the stars, you need to use certain lenses and even mirrors to be able to see so far out into space. Cameras use lenses, and especially binoculars as well as our eyes. They use lenses to be able to focus and produce images for us to see. So, the telescope. That's one we're going to talk about and focus on. There are two types. There's the refracting telescope and the reflecting telescope. So using these two images, pause the video and think about why is it called a refracting versus a reflecting telescope. And then on top of that, think about what kind of lenses or mirrors they use. Hopefully you paused the video. So when you look at a refracting telescope, these types of telescopes use large convex lenses to focus light. Remember, convex lenses focus light, not convex mirrors, convex lenses. And so we call the convex lens that focuses the light the objective lens. The refracted light, because it's a refracting telescope, because it's using a lens which bends light, which is called refracting, the refracted light is then passed through an eyepiece lens, which then also focuses the light. So another question I would ask you then is, well, why do you need two lenses? If the convex lens already focuses the light, why would you want another lens to flip the image? Another convex lens. Well, when you think about it, and if we were to draw, let's say you were looking at this person using a telescope. Okay, well the light from the head goes through the lens and then goes down here. And then the light from the feet go up from the lens and end up here. Well, you would end up with an upside down image, right? The light from the head ended up down here, while the feet ended up over here. Well, kind of sucks to look at an object upside down. So they use another convex lens, not only to increase the focus, but also reflip the image so that now it looks right side up. So it magnifies the image and flips it back. So the convex lens flips the image and magnifies it, and then the eyepiece lens flips it again so that it's right side up. And so that's why you'd have two lenses, or at least two lenses in a refracting telescope. Right? So that explains this question. Why would you need two lenses in a refracting telescope? A reflecting telescope. Well, light is gathered and focused by a large concave mirror, right? Because concave mirrors focus light, not concave lenses. Concave mirrors focus light. And this is called the objective mirror. The light is then reflected again into an eyepiece. Right? So when you look at through a reflecting telescope, light hits the edges of this mirror, right? Like so. Collects at the objective mirror, which is concave, which then focuses the light here. And then all the light bounces up over there. Right? So this video will talk about this in more detail and explain it with more images and visual aid. Binoculars work in a similar way of refracting telescopes, but instead of having long bodies, they use prisms to bend the light. So light will go into the objective lens and focus inwards. And as it hits this prism, it bounces this way. Right? So it allows you to be able to focus on things using a smaller body than a long telescope. In addition, glasses use lenses to correct vision as well. different types of lenses can be used to help the eye focus light better. Two of the most common visual issues are hyperopia and myopia. Hyper means too much, or in this case, far. Opia means to see, or far-sighted. Myopia means near. Myo means near. Opia means sight. So myopia means nearsighted or close-sighted. And in these pictures, they describe how light is reflected through a lens and onto our eyes. So when we look at a normal eye that has normal vision, you can see light will travel through the lens and is focusing. So you may be asking yourself, what kind of lens is that? Check the notes to review that. And it'll strike the back part of the eye. Sorry, that wasn't perfect, but it'll strike the back part of the eye, which will then be sent to the brain and allow us to create an image, and that's how we see, right? Light will be focused from this lens onto the back of our eye, the retina, and it's focused there, and so that's what we'll see. Now, the issue with hyperopia, right? Light is focusing, the focal point is too far back. Sorry, the lines are too thick. The focal point is too far back. So if we were to look at this normal picture, the point where all the light is focusing is here. But if you looked at a hyperopic eye, the point of focus is here, right? So light needs to travel that much further to focus to make a clear image. So that's why it's called far-sighted, because far away things can focus onto the retina, while closer objects, well, the focal point would be too far back. And so the image is blurry when it's close. Myopia, well, the image is focusing here. So if something is close, it doesn't have to travel as far to be focused, and so it's nearsightedness. You can see things close up, while far things don't get focused right on the retina. So these beams of light that were coming from the image would scatter out again, creating that scattered light, right? Because the focus is far back here, the light is still scattered when it hits our retina, creating that blurry vision. So, hyperopia. This happens when the eye focuses the light too far back behind the eye. This causes near objects to look fuzzy or blurry. Right? So light is being reflected off the lens, but because of either how the eye is shaped or how the lens is shaped, it can cause light to focus too far back. Now, light doesn't actually go through our eyes, right? So it stops here. So because the light isn't reaching that focus point, the point where all the light is touching, things are going to look blurry if they're too close. Myopia, well, this happens when light focuses too short in front of the retina, or the back part of the eye, right? So light, based again on whether or not the eye is shaped correctly or if the lens is shaped correctly, the light is being focused too far back, right? It's being focused just short of the retina, and so the light will then scatter again and create a blurry image if something isn't close enough. This video will also talk about myopia and hyperopia in more detail, as well as use more visual aid to help you understand the differences between them. So, what kind of lens would help you with hyperopia? If you were farsighted and the light is being focused too far back, or you wanted to pull the focus closer to the retina, what kind of lens would you use? Well, you would use a convex lens, right? Because a convex lens focuses light. So if you add a convex lens, it already starts to focus the light before it hits the lens, and the lens will then focus it again, creating a shorter focal distance, right? The focal point is pulled back with a convex lens because a convex lens will focus it for you. Myopia, well, you can already see where I'm going with this. What kind of lens would help you with a myopic person? Well, if the light is focusing too far away, if the light is focusing just short of the retina, then you want it to extend the focus a larger distance. You want the light to take longer to focus. Well, then that means you want the light to be further apart. So you'd use a concave lens, right? So as light travels through a concave lens, the light will spread out, causing it to be wider when it hits the eye, and so it'll focus further back, hitting the retina. And so this is why doctors do, or optometrists do that test of, is it blurry or is it clear? Because they're using different types of lenses with different levels of concavity or convexity, I guess, to focus the light in different parts of your eye, right? Because you could be myopic, but the light could be focusing here, and you want a very concave lens to be able to push that focal point back. Or you may only be slightly myopic, and the focal point is here, so you may not need as such a deep concave lens to focus the light onto your retina. And so that's why it's important to know about lenses, how light focuses, and how light can focus on your eyes. So hopefully this was useful. In the next lesson, we'll be talking about parts of the eye. This was just a bit of a warm-up on certain conditions the eyes can have. And now we're going to talk about the important parts that make up the eye and its function. See you next lesson.